Hello everyone, I am Rakhi Wajgi. Today I will explain you shortest path algorithm, that is Dijkstra's algorithm. This Dijkstra's algorithm is used to find shortest path from one source to one destination, that is single source and single destination, or it is also used to find shortest distance from single source to many destination. For example, if we have been given this directed graph, and if we want to find out shortest distance of all the vertices from source, let's say A is a source, then in that case also, that is, you have a single source A and many destinations like B, C, D and E. So this Dijkstra's algorithm is used to find shortest distance from single source to many destination, as well as single source as well and single destination. So there are two purposes of this Dijkstra's algorithm. This is a standard algorithm which you can find in any reference book. Before going for the example, I will explain you what this algorithm is. So this algorithm, the first step is init single source v comma s. So we are calling one function init single source, where this s is a source vertex and v is the set of vertices. So this function, what it is doing, it is setting for each vertex we belong to the vertex set of graph. We are setting distance of all the vertices as infinity. Initially distance of all the vertices from source is infinity, and this pi value of v, that indicate that this v is reachable from which node with minimum distance. So that node we are considering as a parent of v. But initially there is no parent for v, all the parents for all the node is nil. Except for all the vertices we are setting source distance of source is 0. After executing this function, we'll go to step 2. So this S is a set which is initially empty. Q is a priority queue which contains all the vertices with their priorities. So in case of this Dijkstra's algorithm, distance of the edge is considered as a priority. And that distance we are initializing to particular vertex as the algorithm progresses. So while Q is not empty, we have a loop where we are extracting U equal to extract mean Q. So initially this priority queue contains all the vertices along with their weights, that is in terms of D value. So we are extracting a vertex whose D value is minimum. So as we have seen in case of init single source function, we have set D value of all the vertices to infinity except for the source node. So because of this statement, the source get extracted as its D value is 0. After extracting this source in U, we are adding that source in a set S as S union with U. Then for each vertex V which is adjacent to U, so the vertex which is having minimum value is extracted and we are finding which are the adjacent vertices of U. So those adjacent vertices we are considering in V. We are calling a function relax UVW, where W is the weight of UV. After calling this function, what this function relax is doing, it is if the distance of V, if it is greater than distance of U plus weight of UVH, then we are modifying that distance as the lesser distance and we are setting parent of V to U. So what it is doing, if the existing distance of particular vertex is greater than the distance of newly invented vertex, then we are changing that distance to minimum value. So this was about the algorithm. So this we have to do for every vertex, and as the D values get modified, we go on extracting the vertices from Q and we are applying same steps for its adjacent vertices. Now I'll explain this with example in my next video.